Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Kashmir Institute of Excellence. In today's session, we are going to take care of the physics part of your class test. Let's begin with the question number 1. As far as the question number 1 is concerned, it says that two cyclists cycle along circular tracks of radius r1 and r2 at uniform rates. If both of them take same time to complete one revolution, then their angular speeds are in the ratio. आप देख सकते हैं as far as the given information is concerned, it says that T1 is equal to T2. The time of their revolution, that is time taken to complete one revolution, वो दोनों का बेटा यहाँ पे same है. What is the requirement? The requirement for V people is the ratio of their angular speeds. अगर हम बात करेंगे बेटा period of revolution, that can be expressed as 2 pi r upon V. या you can take care of the period of revolution in terms of angular displacement and angular velocity. So that will be given by, in one complete revolution, the angular displacement completed is 2 pi radians and divided by, suppose for body 1 it is omega 1. इसी तरह body 2 की बात करेंगे, angular displacement completed in the one revolution, that will be 2 pi again divided by उसकी angular velocity, that's omega 2. यहाँ से आप देख सकते हैं बेटा 2 pi and 2 pi will go, omega 1 is equal to omega 2, या इनका जो ratio आएगा that is going to be, we will say 1:1. चलिए बेटा next question please. A conical pendulum is moving in a circle with angular velocity omega as shown. If tension in the string is T, which of the following equations are correct? Have a look, my people. This is a conical pendulum. So if we talk about this guy, I'm having the downward force, that's we will say the mg. Likewise यहाँ से आपका बेटा टेंशन है T. अगर T को रिजोल्व करने की कोशिश करूंगा, if this is theta, this is also theta, then this will be T cosine of theta and this is going to be the T sine of theta. आप देख सकते हैं T sine theta is directed towards the center, so it will provide you the required centripetal force. So the equation is going to be T sine of theta is equal to m omega square r, where r is the radius of the circular path. अब यहाँ पे अगर आप radius को देखना चाहोगे, have a look my people, from this triangle this side is L, that's the length of the string actually, और ये बेटा इसका r बनेगा. Using the basic trigonometry you will end with the r will be equal to L sine of theta. अगर आप डिटेल में भी देखना चाहते हो, I have no problem, I will go with the sine of theta, that will be r perpendicular divided by hypotenuse, that's L, so r will be L sine of theta. So I can write it as T sine of theta is equal to m omega square, r के बदले बेटा आपका L sine of theta. We can say bye bye to sine theta and sine theta. You will end with T is equal to m omega square L. That's your option number 1. Next question please. If the radii of circular paths of two particles of same masses are in the ratio of 1:2, then in order to have same centripetal force, their speeds should be in the ratio of. So we are having a situation जहां पे दो particles आपके पास जो है उनके masses जो है वो same है and they are also having same centripetal force. So centripetal force is given by mv square by r. So it is m my people. एक की स्पीड में मानूंगा बेटा v1 विद स्क्वायर और उसका रेडियस में मानूंगा बेटा r1, और दूसरे का मास बेटा बिल्कुल सेम है, दैट्स m ओनली, और v1 की जगह v2 लिखूंगा विद स्क्वायर डिवाइडेड बाय वी विल से द r2. अब रिक्वायरमेंट हमारी यहां पे क्या है? द रिक्वायरमेंट फॉर v people is their speed should be in the ratio of. So we will go with v1 upon v2. So I can say bye bye to m and m. मैं v2 को यहां पे लाऊंगा तो यह आएगा v1 by v2, दोनों का स्क्वायर है तो यहां पे होल स्क्वायर लिख सकते हैं, इज इक्वल टू ये r1 वहां पे ले जाओ बेटा, दिस इज r1 डिवाइडेड बाय द r2. अब यहां से आपको रेडियस का रेशियो दिया गया है दैट्स 1:2, सो इट्स 1:2। फिर यहाँ पे अगर आपको V1, आई राइट डाउन द V1 अपॉन V2 अगर चाहिए तो यहाँ पे स्क्वायर अपियर होगा एज रूट ऑफ 1/2 इज एक्चुअली 1 अपॉन √2। दैट इज योर ऑप्शन नंबर थर्ड। नेक्स्ट वन प्लीज। A heavy vehicle moving with velocity 15 meter per second strikes an object of very small mass at rest head-on elastically. Velocity of object after collision is. हमें collision में special case मिलता है when a huge body, let's suppose of mass m1, going with the velocity u1, hits the light body which is static, which is initially in the state of rest, so the u2 is 0 plus इसका mass बेटा मैं m2 मानूंगा। What is the special case? The case is it's a huge body, the heavier body hitting the light body at rest. Then after collision, what will happen with their velocities? अगर directly cases आपके जहन में है, the answer is the heavier body, and in the given situation, it's a heavy vehicle. It will keep on moving with the same velocity. So v1, that is the velocity of the body one after collision, will be same as that its initial velocity, that is before collision. और ये heavier body बेटा इस lighter body को impact करेगा double velocity, double of itself. So अगर बेटा ये जा रहा था u1 से तो आपका v2 आएगा 2 times of u1. In the given situation, the heavier body was going with the velocity of 15, so जो लाइटर बॉडी है उसकी वेलोसिटी डबल होगी 15 की, दैट्स मारियर 30 मीटर पर सेकेंड। अगर आप ऐसे कंफर्टेबल नहीं है देन यू मस्ट ऑन द वेलोसिटी इक्वेशंस, उसमें आप एक केस ले लो m1 is much greater than m2, you will end with these results, v1 is equal to u1 and v2 is equal to 2 times u1. Next question please. A bomb of mass 30 kg at rest, this is the key point here, explodes into two pieces of masses 18 kg and 12 kg. The velocity of 12 kg mass is 6 meter per second. The kinetic energy of the other mass. Other mass की kinetic energy को निकालने के लिए हम पहले velocity को hit करेंगे and typically the application of the conservation of linear momentum, क्योंकि bomb explosion में किसी external force की involvement नहीं है, so P initial should be equal to, we will say the P final. Now the bomb is initially at rest, so initial momentum is 0. और finally इसके दो fragments हैं, तो definitely just based on the momentum conservation उनके magnitudes जो है linear momentum के वो same होने चाहिए. So I can make the conclusion m1 v1 should be equal to m2 v2, just the constants of the conservation of linear momentum. m1, one of the fragment you are having the 18 that runs with the velocity of, that is 6 is equal to, दूसरा fragment is 12 that runs with the velocity that is given as the v2. So the first I am going to hit my dear v2. जरा v2 को अगर निकालने की कोशिश करेंगे, 6 1r, 6 2r, 2 1r, 2 9r. So typically your v2 is equal to 9, we are in the SI units, 9 meter per second. अब हमें इसी फ्रैगमेंट का बेटा इसी फ्रैगमेंट की काइनेटिक एनर्जी निकालनी है, सो आई कैन राइट डाउन द काइनेटिक एनर्जी 1/2 mv square. 1/2, the mass is 12 kilogram, the velocity we ended with is 9, so ये आएगा 2 1r, 2 6r. Did I make the mistake? Yes, velocity का यहाँ पे स्क्वायर है, so that is 81. So 1/2 mv square, 9 square is 81, 2 1r, 2 6r. तो यहाँ पे आप देखिएगा, if you want to hit the final answer, 6 1r 6 and 6 8r 48, 486 joules should be the answer. Next one please. Okay, a shell of mass m is at rest initially. It explodes into 3 fragments having mass in the ratio 2:2:1. If the fragments having equal mass fly off along perpendicular directions with speed v, the speed of the third fragment is, have a look my people, I am having a bomb or shell जो explode होता है 3 fragments में. One of the fragment here, one of the fragment here as per the question, and based on the momentum conservation, अगर इसका मोमेंटम p है तो इसका भी p है बेटा, just because it says that अगर आप masses का रेशियो देखोगे 2:2:1, so let me take the mass of this fragment as the 2m and definitely इसका भी 2m, ठीक है, और इसकी velocity v as per the question, इसकी velocity भी v, then based on the momentum conservation इन दो का momentum vector बिल्कुल यहाँ पे बाइसेक्ट करेगा, then definitely the third particle must move in this way with the momentum is equal to vector sum of these two. क्योंकि आपको total momentum zero चाहिए as the shell is initially at rest. Based on the momentum conservation, the momentum of the third fragment should be equal to vector sum of the momentum of these two guys. So that will be simply, my dear, root 2 times p if you are taking the p as a momentum of this one and the momentum of this one. And further, अगर यहाँ पे आप p को लिखना भी चाहोगे, it's mass times velocity. The mass is 2m, the velocity is v. And इसी तरह जो third fragment है उसका mass में m लूंगा बेटा. सर कैसे हम ले सकते हैं? My people, you can have a check. बिल्कुल आपको मिलेगा 2:2:1. That is the mass ratio of three fragments. अब यहाँ पे देखो बेटा, I can write it as इसका momentum. The momentum of the third fragment can be written as इसका mass है m, इसकी velocity v dash which is actually the requirement is equal to root 2 times we will say the p. So I can write it as m times v dash is equal to root 2 times p. P is the momentum of these two fragments, that's 2 times mv. It is 2 times mv. I can say bye bye to m and m. V dash will be equal to 2 root 2v. 2 root 2v is the third option as the right one. Next one please. Okay, a ball is thrown from the ground with the velocity u at an angle theta with the horizontal. The horizontal range of the ball on the ground is r. If the coefficient of restitution is e, then the horizontal range after the collision is. So if I draw the physical situation, it will go like this. Initially body को throw किया with some velocity, it will follow the path like this. तो ये आपका range होगा. उसके बाद फिर से ये ball यूं जाएगी बेटा. So this is going to be the target. So if I call this as the r and I call this as the r dash, what's the target? We have to calculate the r dash in terms of the r. पहली बात, अगर मैं r को लिखना चाहूंगा, everybody knows that range is 2 times ux uy. 2 times ux is u cos theta, uy is u sin of theta divided by, we will say the g. This is the first scenario. My people, जब यहाँ पे collision होगा या for the first time when the ball will land, तो इसका vertical component ये है, that is simply the u sin of theta. So that will be actually the velocity of the approach. फिर जब ये वापस को उठेगी बेटा, with what will be the vertical component in that case? So I will say the horizontal component. Suppose this is the velocity. Now I call this as the v for example. तो यहाँ से बेटा इसका वही u cos theta है, और यहां से अब जो कंपोनेंट होगा वो मैं निकालने की कोशिश करूंगा. फॉर दैट आई विल go for the coefficient of restitution. What's the coefficient of restitution defined as? It is velocity of separation divided by velocity of approach. The velocity with which it will be going, लेट अस सपोज वो मैं मानूंगा बेटा v dash. इनफैक्ट हमारा टारगेट यहाँ पे वर्टिकल कंपोनेंट, सो दैट विल बी द v dash ओनली डिवाइड बाय विथ व्हाट वेलोसिटी इट अप्रोच, दैट इज u sin of theta. It is u sin of theta. I hope it is clear. My dear, जब बॉडी को यहाँ से थ्रो किया गया, बॉडी ने यहाँ पे लैंड किया एंड यहाँ पे कोलिजन भी आपका होगा, दैट विल बी इनइलास्टिक. अब यहाँ पे देखो, हॉरिजॉन्टल कंपोनेंट के साथ में कोई छेड़खानी नहीं करूंगा, वर्टिकल कंपोनेंट्स को देखा जाए. द बॉडी व्हेन द बॉडी वाज थ्रोन, द वर्टिकल कंपोनेंट वाज u sin theta. एवरीबॉडी नोज दैट. And it will keep on changing throughout the journey, but जब return होगा, that will be the u sin theta, and it will be the velocity with which the body will be approaching as far as this axis is concerned. So velocity of approach, that is going to be u sin of theta. And suppose अब जब ये वापस उठेगा बेटा, मैंने इसका vertical component v dash माना, which is actually the requirement, or v dash will be equal to e times u sin of theta. अब यहाँ पे आओ बेटा, the r dash जो हमारी requirement है, ध्यान देना, r dash will be equal to formula. The formula is 2 times u cos of theta. अब जो u sin theta है, जो कि मेरा v dash है, that's e times u sin of theta. E times u sin of theta divided by, that is g, या r dash will be equal to, यहाँ पे आओ, मैं इस e को आगे लाना चाहूंगा. What stuff you are left with? 2 times u cos theta, u sin theta upon g, वो आपका r है. So this is going to be the relation. R dash will be equal to e times r is the right answer. Next one please. Two identical balls A and B having velocities of 0.5 meter per second and minus 0.3 meter per second respectively collide elastically in one dimension. The velocities of B and A after collision respectively will be. So we are having a situation, body A जो इनिशियली जा रही है विद द वेलोसिटी ऑफ 0.5 मीटर पर सेकेंड एंड द बॉडी B is going initially with the velocity of minus 0.3 meter per second. Now the two bodies are identical and the collision is elastic, so they will exchange their velocities. So A की velocity after collision will be minus 0.3 and B की velocity after collision will be 0.5. That is the velocity of body A before collision. So B की, it says that, इसमें थोड़ा ख्याल रखिएगा, it's not velocities of A and B, it says B and A. तो B की बेटा 0.5 and A की minus 0.3. The second option is the right one. Next one. Two particles of equal mass m have respective initial velocities ui and u times I plus j by 2. They collide completely inelastically. So the collision is perfectly inelastic. After collision, they will form the single system. The energy lost in the process is, the best approach will be, we will calculate the initial kinetic energy, final kinetic energy, and the difference of the two will be the energy lost in the process. आइए बेटा इधर, let me first take care of the velocity after collision. Have a look. What will be that? Based on the momentum conservation. देखो बेटा, momentum हर एक collision में conserve रहता है. Momentum initial is equal to momentum final. अब initially two particles, एक जा रही है with the velocity ui, so I will say उसका momentum है mass times velocity, that's mu I cap, plus दूसरा जा रहा है with the velocity of this one, that is m times, यहां से u into I by 2, I can write down u by 2 और साथ में I cap, प्लस दूसरा कंपोनेंट उसका mass times u और साथ में j cap divided by 2. I hope it is clear to everyone. This is the initial momentum. Final momentum की बात करेंगे. Finally the two will form the single system having the mass, the sum of the two, that is 2m, and let us suppose they are moving with the velocity now, that is v vector. अब यहां पे बेटा हम v को निकालने की कोशिश करेंगे. I can eliminate m on the both sides. M and m will go. ये है ui plus u by 2i, so that will be 3 ui by 2 plus दूसरा कंपोनेंट आपका है u by 2 with the j cap. यहां से आपको क्या बचा बेटा, 2 times v vector, या v vector can be written as, अगर इस 2 को भी हम नीचे लाएंगे तो ये आएगा 3ui cap divided by 2. जब नीचे आएगा तो यहां पे 2 ऑलरेडी है, that's 4, प्लस बेटा it will be uj divided by the 4. ये आपको मिल गया v. If you want to take care of the magnitude of the v, that will be given by root of, can you help me please, 3u by 4 इसका स्क्वायर ले लो, वो आएगा 9u square by 16, 9u square divided by the 16 plus square of u is u square divided by square of 4 is my dear 16. अब यहां पे आओ बेटा, v will be equal to 16 कॉमन, रूट से बाहर आएगा 4, ये है 9 u स्क्वायर, ये u स्क्वायर तो 10 u स्क्वायर, तो u भी बाहर आएगा, सो दिस विल बी एक्चुअली रूट ऑफ 10 और बचेगा u यहां पे और डिवाइड बाय 4. दिस इज एक्चुअली द वेलोसिटी, द फाइनल वन, द कॉमन वेलोसिटी ऑफ द टू पार्टिकल्स. इससे मुझे क्या मिलेगा बेटा, आई कैन टेक केयर ऑफ द फाइनल काइनेटिक एनर्जी. सो प्लीज कैन हेल्प मी इन रिमेंबरिंग द रिजल्ट. द v is equal to, I guess it was root of 10 divided by the 4 multiplied by the u. So if I will calculate from here final kinetic energy, that will be 1 upon 2 mv square. Now the two particles undergo perfectly inelastic collision, they will form the single system. So the mass is 2m with the velocity square, तो ये बनेगा root of 10 का स्क्वायर है 10, 4 का बनेगा 16 और यहां से आपका u square. So this will be the k final. The k final is going to be, यहां से आपका 2 और 2 चला जाएगा, 2 5r 2 8r. So if I'm not wrong, it will be 5 upon 8 और साथ में आपका बेटा mu square. This is going to be the final kinetic energy. अब initial kinetic energy की बात करेंगे बेटा. The particle 1 was having the velocity of, if I'm not wrong, it is ui. The another particle was having the velocity of, I guess it was u by 2 with the I cap plus j cap. We can have a check. It is ui and u by 2 I cap plus j cap. तो इनिशियल काइनेटिक एनर्जी की अगर हम बात करेंगे तो इसकी वेलोसिटी u है, सो k इनिशियल में कंट्रीब्यूशन होगा दो वेलोसिटीज का या दो पार्टिकल्स का, दैट्स k1 प्लस वी विल से द k2. अब k1 को निकालना चाहूंगा, इसकी वेलोसिटी है u, 1/2 सीधे आएगा mu स्क्वायर. अगर इसी तरह बेटा हम k2 को निकालना चाहेंगे, इसकी वेलोसिटी क्या आएगी बेटा, इट्स गोइंग टू बी, इफ आई एम नॉट रॉन्ग, First I will try to calculate the magnitude of the velocity here. So that will be equal to root of ui by 2, that is u square by 4, plus इसकी क्या बनेगी बेटा, uj by 2, that is u square by 4 again. So that will be, u will be out, 2 will be out, साथ में आपको root 2 मिलेगा. So root 2 times u upon 2. So if you take care of the k2, kinetic energy of the particle 2, that's 1 upon 2, the mass is m. Velocity की बात करेंगे उसका स्क्वायर, तो वो बनेगा बेटा u square root 2 का स्क्वायर 2 divided by, we will say the 4, 2 and 2 will go, if I'm not wrong it is mu square upon 4. So k initial की अगर हम बात करेंगे, that will be the sum of these two. ये आएगा 1 by 2 mu square plus mu square by 4, that will be I guess 3 mu square upon 4. ये आपको मिल गई बेटा k initial. अब हमें चाहिए बेटा loss in energy, so that will be the difference of the two. Definitely the initial will be greater, so I will just calculate the difference, या the loss in kinetic energy. Even if we calculate it as the final minus initial, no problem at all, you will end with the negative result, which will signify that the final energy is less than the initial. But there is nothing wrong if I will go with this one, 3 by 4 mu square minus 5 by 8 mu square. अब इसको यहाँ पे सिंप्लीफाई करो बेटा, तो कितना आएगा, 3 8 are 24 minus 5 4 are 20. 24 minus 20 is 4 only, with the mu square in the denominator it is 4 into 8. 4 and 4 will go, mu square by 8. Check the option please. Definitely mu square by 8 is the right one. Next one please. A bomb is kept stationary at a point. It suddenly explodes into two fragments of masses 1 gram and 3 gram. The total kinetic energy of the fragments is 6.4 into 10 raised to power 4 joules. What is the ratio of kinetic energies? Because since collision, जब यहाँ पे explosion होगा, the two fragments they will be moving with the equal momentum in terms of the magnitude, just the consequence of the momentum conservation. Bomb initially stationary, initial momentum 0. For the final momentum to be 0, they must have equal momentums and the direction should be opposite. So it's clear that the P1 is equal to P2 and both are equal to the P. The target for V people is the ratio of the kinetic energies. So I can write down the kinetic energy as one of the relation as the P square upon 2m. P दोनों का same, 2 is just a number, m will be the deciding. So I can write down the k1 by k2, m के साथ inverse relation है, that will be m2 by m1. अब m2 आपका 3 gram है और m1 आपका 1 gram है, so 3:1 should be the answer, the option 1. Next one please. A sphere of mass 0.1 kilogram is attached to a cord of 1 meter length. Starting from the height of its point of suspension, this sphere hits a block of same mass at rest on a frictionless table. If the impact is elastic, then kinetic energy of the block after the collision is. What I'm going to do, मैं बेटा निकालूंगा जब यही बॉब यहाँ पे पहुंचेगा इसकी वेलोसिटी क्या होगी. And more important, they are identical. So at this instant, the collision is elastic. The bodies are identical. They will exchange their velocities. This one is initially at rest, and this one will reach here, suppose with the velocity u. Then after collision, this will be in the state of rest, and this will start moving with the velocity u. So I need to calculate the kinetic energy of this one. For that, I will calculate the velocity, which will be exactly the velocity of this one जब यहाँ पे पहुंचेगा. For that, I will go with the conservation of mechanical energy. I'll write down mgh. If you take this as the reference, at this point only energy is the potential. mgh will be equal to 1 upon 2 m with the u square. m and m will go. आपका u square आएगा बराबर बेटा 2gh. अब kinetic energy को निकालो. It is 1 upon 2 m. The velocity, the whole velocity will be exchanged or transferred to this one, so it will start moving with the velocity u. So u square के बदले बेटा इसका आएगा 2gh. 2 and 2 will go, so that will be the mgh only. So m is mass given, yes, 0.1. I want to write it here. Into g is 10 into h. What is height by the way? Can you help me? 1 meter only. So 10 into 0.1 is 1 only. So 1 joule is going to be your answer. Next one. Considering a system having two masses m1 and m2 in which first mass is pushed towards center of mass by distance a, the distance required to be moved by second mass to keep the center of mass at same position. एक प्रॉब्लम का पैटर्न डेफिनेटली आपने फेस किया होगा जहां पे जब आप दो पार्टिकल्स को डिस्प्लेस करते हो बट यू डिस्प्लेस देम इन सच अ वे, इन सच अ मैनर कि सेंटर ऑफ मास अपनी ही पोजीशन पर रहता है. द सिचुएशन इन दैट केस, द इक्वेशन इन दैट केस इज डेल्टा x1 डिवाइडेड बाय डेल्टा x2 इज इक्वल टू माइनस टाइम्स m2 divided by, we will say, the m1. Delta x1 is change in the position of the particle 1, delta x is the change in the position of the particle 2. The minus just signifies कि अगर ये वाला mass suppose towards right चलेगा then center of mass को अपनी जगह रखने के लिए इसको towards left चलना पड़ेगा. अब यहां पे आओ बेटा, फर्स्ट मास इज पुश टुवर्ड्स सेंटर ऑफ मास बाय डिस्टेंस a. सो डेल्टा x1 आपका a है डिवाइड बाय डेल्टा x2 इज द रिक्वायरमेंट. आई विल स्किप द नेगेटिव साइन, वी नो इट्स इंपॉर्टेंस. m2, सो आई विल राइट डाउन द m2 डिवाइड बाय वी विल से द m1. अब डेल्टा x2 को निकालने के लिए m1 यहां पे आएगा तो ये आएगा m1a और m2 नीचे चला जाएगा और बेटा डेल्टा x2 यहां पे आएगा. चेक द ऑप्शंस प्लीज. m1a डिवाइडेड बाय m2, m1a डिवाइडेड बाय द m2 इज द राइट वन. नेक्स्ट वन प्लीज. A particle of mass m is fixed to one end of a light rigid rod of length L and rotated in a vertical circular path about its other end. The minimum speed of the particle at its highest point must be. Recall, there is a case that the minimum speed for orbiting, for looping is root of 5gl. फिर जब आप बेटा velocity equation से इसी particle की velocity को यहाँ पे देखते हो बेटा, then that is simply the root of, we will say, the gl. So the right answer is root of gl. root यहाँ पे l को b है. Next one please. The minimum speed for a particle at lowest point of a vertical circle of radius r to describe the circle is v. So इसका मतलब v आपको दिया गया है root of, if I am not wrong, that is root of 5gl or 5gr, whatever it is. So this is actually the minimum. If the radius of the circle is reduced to 1/4 its value, 1/4 of its value, the corresponding minimum speed will be, now suppose the minimum speed is v dash is equal to root of 5g. Now you are reducing the radius to its half, so it will be reduced by l by 2. तो यहां पे देखो बेटा, let's go for this one now. So your v dash in this case will be, is it 1/4? I'm sorry, it's not half, it is 1/4. It is 1/4. So I can write down the v dash is equal to, यहां पे आओ बेटा, root of 5gl आपका v है डिवाइड बाय रूट में 4 वो बाहर आएगा is 2. So v dash will be equal to the v upon 2. That is your option number 2. Next one please. The velocities of three particles of masses 20 gram, 30 gram and 50 gram are 10i, 10g and 10k. The velocity of the center of mass of the particles will be, if you talk about the VCM, you express your VCM as m1 v1 plus it is m2 v2 plus it is m3 v3 divided by the total mass, that is m1 plus m2 plus m3. I can write it as the capital M. Here VCM will be equal to m1. m1 is 20 gram multiplied by उसका velocity at 10i. So 20 into I will go with the 10i. No need of unit conversion at all. Next one is 30 gram into उसकी velocity 10g. Next one is 50 gram उसकी velocity 10k. In the denominator the total mass 20, 30, 50, that's 100. That's 100. Now if you want to hit the final answer please, हर टर्म में दो जीरोस आपको मिलेंगे ये बेटा, और आई कैन से मैं 100 को कॉमन निकालूंगा, बचेगा क्या 2i plus 3j plus 5k. 2i plus 3j plus 5k is the right one. Next question. Two uniform rods of same length but made of the different materials are kept as shown. If the meeting point is the origin, then coordinates of center of mass are. The two rods, even if they are having the different materials, they can be replaced by the point masses. इनका center of mass तब भी उनके geometric center पे होगा. अब इस पॉइंट की बात करूंगा, the coordinates will be, the point lies on the x-axis, the coordinates will be l by 2, 0. And इसकी बात करेंगे, the coordinates will be 0, l by 2. So these will be the coordinates, my dear. अब यहां पे आप करते हैं m1x1 प्लस m2x स्क्वायर ऑल दैट, बट masses की कोई इंफॉर्मेशन नहीं दी गई है, दे आर नॉट हैड इट बीन द सेम मटेरियल, तो तब आप अगर एक का मास m लेते दूसरे का मास भी m। बट एक बात तो पक्की है, व्हेन यू रिप्लेस द टू रॉड्स बाय दीज टू पार्टिकल्स, सेंटर ऑफ मास विल लाई ऑन दिस लाइन, वो तो पक्की बात है बेटा हमारे लिए, ठीक है। देन अगर मैं इस लाइन की इक्वेशन की हम बात करेंगे, रिकॉल द इक्वेशन ऑफ द स्ट्रेट लाइन एज y इज इक्वल टू mx प्लस c, ठीक है। आई राइट डाउन द y। अगर स्लोप की बात करेंगे बेटा, स्लोप इज गिवन बाय द tan ऑफ थीटा, तो ये साइड और ये साइड बिल्कुल बराबर है, सो tan 45 आएगा, दैट विल बी द 1, लेकिन इसका स्लोप नेगेटिव है, सो दैट विल बी द -1 इंटू एक्स प्लस इंटरसेप्ट ऑन द y एक्सिस वो है आपका बेटा l अपॉन 2, या ये बनेगा y -1 इंटू एक्स इज -x, यहां पे लाओ y माइनस एक्स इज इक्वल टू l बाई 2। अब देखो बेटा इन द गिवन, सॉरी y प्लस माइनस एक्स को यहां पे मैंने लाया बेटा। अब देखो गिवन ऑप्शंस में कि क्या कोई ऑप्शन है जो इसको बेटा मैच करेगा, y प्लस एक्स इज इक्वल टू l बाई 2, l बाई 2 प्लस l बाई 2 is l only, so that's not going to work। 2l by 3 plus l by 2, that is not equal to l by 2, l by 3 plus l by 3 is 2l by 3, that's not equal to l by 2, so we'll be quite comfortable with the fourth option as the none of these। Next one please, two bodies of masses 1 kilogram and 2 kilogram are lying in xy plane at -1, 2 and 2, 4 respectively, what are the coordinates of the center of mass? So I will directly go for the axiom first, that will be m1 x1, 1 into x coordinate इसका -1 आएगा, प्लस बेटा 2 और इसका x कोऑर्डिनेट 4 है, 2 इंटू इसका x कोऑर्डिनेट 2 है, डिवाइड बाय द टोटल मास विल बी 2 plus 1 is 3, so that will be 2 2 or 4, 4 minus 1 is 3, 3 upon 3 is 1, so that's your axiom। ycm की बात करेंगे, y कोऑर्डिनेट ऑफ सेंटर ऑफ मास m1 y1, 1 इंटू उसका y कोऑर्डिनेट 2 है, प्लस 2 इंटू इसका y कोऑर्डिनेट 4 वो 8 है, डिवाइड बाय द टोटल मास 1 plus 2 is 3, 8 plus 2 is 10, 10 by 3, so 1 10 by 3, that is option 2 is the right one। Next one please, the coordinates of a triangle ABC are 1, 2, B is 4, 6 and C is -3, -2, three particles of masses 1, 2 and m kilogram are placed at the vertices of the triangle if the coordinates of the center of mass are 3 by 5, 2, then the mass m is, have a look, x coordinate मुझे given है, so I will use that as 3 by 5, even if I can go with the y coordinate also, is equal to m1 x1, एक का मास है m, उसका कोऑर्डिनेट बेटा x कोऑर्डिनेट बेटा 1 है, सो आएगा 1 into 1, प्लस दूसरे का मास है बेटा 2 और उसका x कोऑर्डिनेट है 4, 2 into 4, और तीसरे का मास बेटा m है विच इज इनफैक्ट द रिक्वायरमेंट, और उसका x कोऑर्डिनेट -2 है, इट इज -2 हियर, डिवाइड बाय द टोटल मास विल बी 1 plus 2 plus m, दैट इज 3 plus m। नाउ यू आर हैविंग ए सिचुएशन जहां पे सिर्फ आपके पास एक वेरिएबल है, एक अननोन है। आइए बेटा इधर 3 3 और 9, 9 plus m आएगा ये वाला साइड, 9 plus m, 9 plus 3m, 3 3 और 9 प्लस 3 इंटू m इज 3m इज इक्वल टू, यहां पे आइए बेटा 1 1 और 1 प्लस 4 2 और 8, 8 plus 1 is 9, 9 5 are if I'm not wrong 45, और यहां से -2m into 5 is -10m। Let us simplify it further, 9 को वहां पे लाओ, 45 minus 9 that will be the 36, -10m को यहां पे लाओ तो +10 वो बनेगा 13, -10 को यहां पे लाओ तो +10 बनेगा, that will be the 3 13, did I make the mistake, 13m, wait on, 3 3 or 9 and 3m, 1 8 5 9 or 45, okay fine with it, 5 into -2 is -10m, fine, it's 13m, and 45 minus 9 is 36। Any mistake which we made? Coordinates को एक बार फिर देखो, 1 into 1 m1 x1 plus m2 x2, m2 is 2, x2 is 4, that's fine again, m3 is m into -3, oh here we have made the mistake, the x coordinate is -3 here, so ये बनेगा 5 3 are 15, so 15m, all right। चलिए बेटा अब फर्दर सिंपलीफाई करो, so 45 प्लस 9 को यहां पे लाओ, So what will be that? That will be the 36. And minus 15 को यहाँ पे लो, plus 15 plus 3, that's 18m. So m will be equal to 36 by 18, that's 2 kilogram should be the answer. You can solve the same by using the y coordinate, क्योंकि y coordinate भी आपको दिया गया है. Next one please. Two particles of equal masses are moving along the same straight line with the same speed v in opposite direction. What is the speed of the center of mass of the system when they are moving in the opposite direction? So mv term subtract होंगी बेटा. Their identical masses are same, they are moving the same speed, that will be mv minus mv divided by total mass is 2m. You will end with the answer, that is 0. So 0 is the right answer. Next one please. In which of the following cases the center of mass of a rod may be added as center? The linear mass density decreases continuously from left to right. No, it will be on the left side of the midpoint, क्योंकि linear mass density continuously decrease हो रही है. The linear mass density increases continuously from left to right. No, it won't be added as geometric center. अब यहाँ पे आओ, the linear mass density decreases from left to right. So if I draw the physical situation, one of the case, the possible case is like this, then up to the center and then increases, then it may go like this. So there is a possibility of the center of mass at the center. ये वाला बेटा. So this is fine. D पे the linear mass density increases from left to right. So ये केस बन सकता है इसका, ठीक है. Up to center and then decreases, then it may go like this, ठीक है. So this is a situation. So C and D is going to be the right one. Next one please. If the linear mass density, mass per unit length of a rod of length 3 meter is proportional to x, so I can say the linear mass density lambda can be written as the kx, where x is the distance from one end of the rod, the distance of the center of the gravity of the rod from this end is. For continuous mass distribution, if you want to go for the axiom, it is given by integral dm into x divided by, I will say the integral dm, which is equal to integral dm. इंटीग्रल dm is my dear lambda into dx, so that will be lambda आपका kx है multiplied by dx, और यहाँ पे आपका x है divided by integral dm के बदले वही lambda into dx, that is kx into dx. And what are the limits? From 0 to L and the length is given as a 3, 0 to 3. Come on, solve the integral now. यहाँ पे आइए, k can be eliminated in numerator and denominator. K and k will go. तो ऊपर x into x, x square है, उसकी इंटीग्रेशन बनेगी बेटा x cube upon 3 and the limits are from 0 to 3. In the denominator, x की इंटीग्रेशन x square by 2 and the limits are from 0 to 3. तो थोड़ा rearrange करने के बाद 2 ऊपर चला जाएगा, so that will be the 2 by 3, ठीक है, ये वाला 3. अब यहाँ पे x cube upper limit दे दो, so that will be the 3 cube माइनस 0 लिखने की जरूरत नहीं है, यहां पे अपर लिमिट x की जगह दैट विल बी द 3 स्क्वायर. जरा इसको सिंप्लीफाई करो बेटा. सो 3 क्यूब, 3 स्क्वायर into 3 is 3 cube. This will go, you are left with the 2 only. So 2 is going to be the answer. No, that's none, so none is the right one. Next one please. Find the acceleration of the center of mass of the system. अगर given system की बात करेंगे, we have to go for the acceleration of center of mass. For that we must know the acceleration of these two guys. Suppose this is going down with the acceleration a, definitely this will move towards right with the same acceleration a. Then the acceleration from the basics of the dynamics can be calculated as, इस पे डाउनलोड फोर्स आपका 2g होगा and यहाँ से मेरा फोर्स ऑफ फ्रिक्शन होगा. So I'll write down acceleration is net force 2g minus force of friction is mu times n, mu times mg, that will be 0.5. इसका mass है 3 and the g is 10 divided by the total mass 3 plus 2 is 5. अब यहाँ से देखो बेटा, it will be 20, 10 into 0.5 is 5, 5 3 are 15, so it's minus 15 divided by the 5, so that will be the 1 meter per second square इनकी acceleration. अब इसकी क्या होगी बेटा, इसकी होगी I as acceleration, इसकी बेटा minus j. अब यहां पे आओ, I will go with the acceleration of the center of mass. What is that? m1a1 plus m2a2 divided by m1 plus m2. अब यहां पे आओ, m1a1, so that will be 3 into 1 is 3, or divided by total mass. If I'm not wrong, I can write it as 3 by 5 with the I cap. इधर आइए बेटा, m1a1 इसका mass है 3, acceleration 1 है बेटा, so that's 3 into 1 is 3, और divided by total mass आपका 5, plus इसकी बनेगी बेटा m2, that will be the 2 इसकी एक्सेलरेशन 1 है, ठीक है, और डिवाइड बाय टोटल मास वो आपका कितना है 5 है, देन यू विल गो विद द माइनस जे कैप. नाउ चेक द आंसर्स. नो देयर इज नो वेक्टर नोटेशन, मैग्नीट्यूड निकालना है, तो दैट विल बी द रूट ऑफ व्हाट इज इट, यहां पे लिखना चाहूंगा एक्सेलरेशन. अगर मैग्नीट्यूड में आपको चाहिए दैट विल बी द रूट ऑफ 2/5 with the square plus it is 3/5 plus 2/5 ये बेटा. So that will be the 4 plus 9 divided by 25 with the root. 9 plus 4 is 13. 13/5. Root 13/5 should be the answer, not this one. क्योंकि 25 का root 5 आएगा बेटा. Next one. Two blocks of mass is 5 kg and 2 kg are connected by a spring of negligible mass and placed on a frictionless horizontal surface. An impulse provides a velocity of 7 meter per second to the heavier block. In the direction of the lighter block, the velocity of the center of mass is. Velocity of the center of mass will be given by m1v1 plus m2v2. So an impulse that is force into time, वो कितनी वेलोसिटी इंपार्ट कर रहा है 7, किसको, हेवियर को. सो उसका बनेगा m1 v1 है 7 into 5 that is 35 divided by the total mass is 5 plus 2 is 7, 35/7 that is my dear 7 meter 5 meter per second should be your answer. Because while calculating m1 v1 plus m2 v2, एक में आपकी mv term 0 होगी because an impulse provides a velocity of 7 meter per second to the heavier block only. So 5 should be the answer. Next one please. A particle of mass m is thrown horizontally from the top of a tower and another particle of mass 2m is thrown vertically upward. The acceleration of the center of mass is, so this is the situation, particle 1 thrown in this way, particle 2 thrown in this way. But एक बात तो पक्की है बेटा, the only acceleration for this particle will be g in the downward direction, the only acceleration for this particle will be g in the downward direction. So if you will go with the acceleration of the center of mass ACM, that will be equal to, are they identical? नहीं, दूसरे का मास 2m है, नो प्रॉब्लम. एक की मास m, एक्सेलरेशन मेरा g डाउनवर्ड डायरेक्शन में, तो माइनस जाएगा, माइनस यहां पे लिखूंगा, j यहां पे लिखूंगा. देन अनदर पार्टिकल ऑफ मास 2m, सेम एक्सेलरेशन g इन द डाउनवर्ड डायरेक्शन, सो दैट इज माइनस j कैप डिवाइड बाय द टोटल मास दैट विल बी द 3m. कम ऑन, m can be eliminated here. Minus g and minus 2g along with the j cap is minus 3g j cap divided by the 3 only, 3 and 3 will go. So the acceleration of center of mass will be minus g j cap, in magnitude it will be the g only. Next one please. A man of mass m is suspended in air by holding the rope of a balloon of mass m. As the man climbs up the rope, the center of mass, it will remain stationary as it was stationary initially. Man जो force लगाएगा बेटा, that will be internal force. VCM is not affected by the internal force. In order to have the center of mass at the same position, जब मैन ऊपर क्लाइम करेगा तो बलून भी नीचे आएगा. So it will remain stationary. Next one. A circular plate of diameter A is kept in contact with a square plate of side A as shown. The density of the material and thickness are same everywhere. The center of mass of composite system will be. Have a look my people. So इसका diameter बेटा A है और इसकी side length वो भी A है. Now we know center of mass will lie towards the region of greater mass. अब mass की information direct नहीं दी गई है, but there is no problem we can use the relation that mass is proportional to area. अब area देखो इसका ज्यादा आएगा, इसका diameter a है तो radius a/2 बनेगा, तो इसका area बनेगा बेटा pi a square by 4, because diameter will be a/2 तो उसका स्क्वायर बनेगा a²/4. तो यहाँ पे इसका area बेटा जो है that will be the a square only. अब देखो बेटा pi/4 is less than 1, pi is 3.14 and यहाँ पे a square, so the area of square is greater, या mass of the square will be greater, so the center of mass will be inside the square plate. Option 2 is the right one. Next one please. Three identical spheres of mass m each are placed at the corners of an equilateral triangle of side 2 meter, taking one of the corners as the origin. The position vector of the center of mass is. Have a look my people. This is the situation. Three particles. Three identical spheres of mass m each are placed at the corners of an equilateral triangle of side 2 meter. So, if I take this as an origin, and this is the x-axis and this is the y-axis, we have to go for the RCM, position vector of center of mass. बेटा ये वाला origin पे है तो इसका position vector null vector होगा. इसकी बात करेंगे, इसका position vector simply अगर 2m आपकी length है तो 2m I cap आएगा. So I'll write down the RCM, position vector of center of mass. They are identical. So m in fact common में निकाल सकता हूँ बेटा. इसका position vector कुछ भी नहीं, ठीक है, और null vector. इसका क्या बनेगा? The coordinates will be, can you help me please? 2m comma 0. So it will be 2i cap plus इसका position vector. सर इस पॉइंट के coordinates बोलो मुझे बेटा. That will be the 1, क्योंकि ये 2 है, और दूसरा coordinate क्या आएगा? This is the 60, और ये 2m है, ये 2 meters है, तो यह आएगा 2m sin 60, ठीक है. तो 2 meters into sin 60 is root 3 by 2. 2 and 2 will go. तो इसका दूसरा coordinate, if I am not wrong, that will be the root 3. तो इसका position vector बनेगा I plus root 3j divided by the total mass, that will be the 3m. M and m will go. Can you help me please? RCM will be equal to 2i plus I is 3i. 3i by 3 is I only, plus root 3j divided by 3, या यहाँ पे रूट 3 और रूट 3 को ऐसे बेटा मैं मल्टीप्लाई कर सकता हूं. सो इट विल बी इक्वल टू आई प्लस रूट 3 इंटू रूट 3 इज 3, वो 3 और ये 3 चला जाएगा. सो दैट विल बी j by root 3. सो I plus j by root 3 should be your answer. That is the option number 4. Next one please. A force mv square by r is acting on a body of mass m moving with a velocity v in a circle of radius r. What is the work done by the force in moving the body over half of the semicircle? My dear, the force involved is the centripetal, and the work done by the centripetal force is simply 0. Next one. Figure shows a body of mass m moving with a uniform speed v along a circle of radius r. The change in speed, as the speed is uniform, so the change in speed will be simply the 0. हाँ, अगर change in velocity का case होगा बेटा, then the situation was entirely different. You have to go for the vector difference. Final velocity minus initial. Next one please. A circular disk of radius r is removed from a bigger disk, a bigger circular disk of radius 2r, such that the circumferences of the disk coincide. So अगर ये आपकी बेटा एक bigger disk है, have a look. Then the another one is like this. ये बेटा, this is having the radius r, और complete disk का radius जो है that's my dear 2r. We have to calculate the center of mass of the new disk is alpha r. So we have to go for the alpha. अब इसमें conventional approach वही है आपका बेटा. m1 you will go with the m1 x1 minus m2 x2 divided by m1 minus m2. But disk के लिए आपके पास एक direct result है. HCM of the disk is given by d divided by n square minus 1, where d is the distance between the centers. वो कितनी है यहां से यहां तक बेटा? That is simply the r divided by, what is n? N is the ratio of the radius of the complete to the removed part. Radius of the complete is 2r, the removed part is having the radius r and r will go to 2 आएगा, 2 का स्क्वायर बनेगा 4 minus 1, तो यह आएगा बेटा बराबर r by 3. And compare it with the given form that is given as the alpha times r. So alpha का वैल्यू 1 by 3 आएगा. So first option is the right one. Next please. When a ceiling fan is switched on, it makes 10 revolutions in the first 3 seconds. Assuming a uniform angular acceleration, how many rotations will it make in the next 3 seconds? But a famous case है, kinematics 1D में भी देखा होगा. If the body covers the displacement of x in the first 3, yeah, I can generalize it in the first t seconds, then the displacement covered in the next t seconds is 3 times of that. Likewise, you can have the same in the circular motion. If the body covers the displacement theta in the first t seconds, maybe 5, 10, whatever it is, then the displacement covered in the next t seconds is theta dash, and they satisfy the relation. theta dash is equal to 3 times of theta. And अगर यहाँ पे बेटा मैंने बात की in terms of angular displacement, तो जो number of revolutions है they will also be related, they will also show same relation. So I'll say when the theta dash is 3 theta, the accordingly the revolutions अगर 10 थे बेटा पहले 10 सेकेंड में या पहले 3 सेकेंड में, तो नेक्स्ट में आपके बेटा 30 होंगे. That's going to be your answer. You can take care of this question in detail as well. Next one please. If a body moving along a circular path has constant speed, then there is no force acting on it. No. There is every time a force. The force responsible for the normal acceleration, the force responsible for the circular path, the force responsible for the change of direction. So this one is, I will say, the wrong one. The direction of velocity of a body moving in a circular path is not changing. It is every time changing. So this is wrong also. So both assertion and reason are false. Next one. If the equation for the displacement of a particle moving on a circular path is given by theta is equal to 2t cube plus 0.5, where theta is in radians and t seconds, then the angular velocity of the particle after 2 seconds from its start will be. Angular velocity can be written as d theta divided by dt, which is given by 2t cube का आएगा बेटा 6t square. We have to go for it at t equal 2 seconds. After 2 seconds, 2 square is 4, 6 4 are 24. So omega after t is equal to 2 seconds will be equal to 24 radians per second. 24 radians per second is the answer. Next one please. The angular acceleration of a body moving around the circumference of the circle is along the axis of rotation. I guess Neet 2023 का asked question है. Next one. A ball falls from rest from a height h onto a floor and rebounds to a height h upon 4. The coefficient of restitution between the ball and the floor is, recall the relation, hn is equal to e raised to power 2n into, my people, we will say the h. Height after nth rebound, that's in fact the first rebound, that's h by 4 is equal to e raised to power 2n की जगह 1 into h originally है. h and h will go, e square या e will be equal to square को यहाँ पे लाओ आएगा root of 1 by 4, that's 1 by 2. So 1 by 2 is going to be your answer. Next one please. When a shell traveling along a parabolic path in the gravitational field explodes in the mid-air, the center of mass of the fragments will continue to move. Explosion की वजह से कोई external force वजूद में नहीं आएगा, so the center of mass will keep on moving along the same parabolic path, along the original parabolic path. Next one please. The height attained after nth rebound in bouncing ball problem is proportional to, अभी हमने आपके साथ शेयर किया बेटा, hn is equal to e raised to power 2n into h, so you can see hn is proportional to e raised to power 2n. That's your answer. Next one please. A stationary radioactive nucleus of mass 210 units disintegrates into an alpha particle of mass 4 units and a residual nucleus of mass 206 units. If the kinetic energy of the alpha particle is E, the kinetic energy of the residual nucleus is. एक बात तो पक्की है बेटा, it was stationary initially, so initial momentum is 0. Explosion में, disintegration में कोई external force involved नहीं है, so final momentum should be 0. For that, the magnitudes of the two fragments should be equal. So what we have to take care of, the kinetic energy of the residual, I can say the E of alpha divided by the E of residual is equal to mass of residual divided by mass of alpha. कहां से लाया बेटा? Kinetic energy in terms of the momentum is given by p square upon 2m. p दोनों का same based on the momentum conservation. 2 is just a number, E is inversely proportional to m. That is what I have mentioned here. If the kinetic energy of the alpha particle is E, so E alpha के बदले E divided by ER आपको चाहिए is equal to mass of the residual nucleus is 206, mass of the alpha particle is 4. अब यहाँ पे थोड़ा इसको सिंप्लीफाई करो, 2 2r 2103r. आपको क्या चाहिए? ER को यहाँ पे लाओ, 2 यहाँ पे आएगा, 2e by 103. 2e by 103 is the answer. Next one please. A ball hits the floor and rebound after inelastic collision, so there will be loss of energy. In this case, the momentum of the ball just after the collision is the same as that just before the collision. No, the mechanical energy of the ball remains the same in the collision. No energy will be lost. The total momentum of the ball and earth is conserved. That is 1,000,000% right. Option third. Next one. Let AR and AT represent radial and tangential acceleration. The motion of the particle may be circular if, my dear, circular motion के लिए direction का change होना जरूरी है, essential है. So means A radial should be non-zero. A tangential may be zero or may not be zero, depending upon the motion is uniform, circular or non-uniform. So I can say A radial 0. Sorry, the motion cannot be circular. The motion cannot be circular. However, A radial is non-zero, so motion is going to be circular. Next one. Consider the elastic collision of two bodies A and B of equal mass. Equal mass, exchange of velocity. Initially B is at rest and A moves with the velocity V. After the collision, the body A comes to rest and body B moves away in the direction A's approach with the velocity V. बिल्कुल बेटा. Body B initially at rest and A moves with the velocity V. After collision, they will just exchange their velocities. Next one. A ball is allowed to fall from a height of 10 meter. If there is 40% loss of energy due to impact, then after one impact, the ball will go up to. So I can write down, after losing the 40% energy, let us suppose it goes up to the height h, then the potential at that height will be mgh dash. That will be only not 100% of mgh but only 60%, क्योंकि 40% loss हुई, that is 60 by 100 of mgh. mg and mg will go, h dash आपको चाहिए, so h आपको दिया गया है 10 meter, so that will be 600 divided by 100. Two zeros will go, 6 meters is the answer, the option number 2. Next one please. Consider a system of identical particles. One of the particles is at rest and the other has an acceleration f. The center of mass has an acceleration of. Acceleration of the center of mass will be m1, a1. The masses are identical. एक की acceleration f है बेटा, दूसरे की कुछ भी नहीं है, तो a2 आपका 0 है, divided by total mass is 2m. m and m will go, so that will be equal to f upon 2. f upon 2 is going to be the answer. Next one. A curved rod of radius 90 meter is banked so that no friction is required at a speed of 30 meter per second. What is the banking angle? Banking angle की बात करेंगे, the expression is tan theta is equal to v square by rg. The v is given as the 30, उसका square बनेगा 900. The radius is 90. g आपका बेटा 10. I can say bye bye to those 20 and 20. 9 by 9 is 1. tan function का value 1 होता है 45 पे. I guess the last question. Two particles A and B initially at rest, this is key, move towards each other under a mutual force of attraction. At the instant when velocity of A is V and that of B is 2V, then velocity of the center of mass of the system is. The mutual force of attraction will be just an internal forces, and VCM, velocity of center of mass, is not affected by the internal force. So it was, the particles were initially at rest, means initially VCM was 0, so it will remain as 0. So that was from today's session. See you next time, inshallah.